Hi guys! So today we're going to be talking about Chapter 4, Section 7, Piecewise Functions. So what is a piecewise function? A piecewise function is a function that is defined by two or more equations. And the way that we write our piecewise function is in this format or this notation. Now what this is showing us right here, it's showing us that we have two equations on our graph. The first one that's being shown is f of x equals to negative x if our x value is smaller than or equal to 0. So I can show that here on this graph. We have the linear equation f of x equaling to negative x. Now, this point, or this image, stops at x being less than or equal to 0. So that means that it stops at 0, and it has to be any part of the x-axis that is smaller than 0. So this ordered pair right here, we could show this as negative 1, comma 1. As you can see here, this point is negative 1, and so that counts because negative 1 is less than or equal to 0. We also have here negative 2, comma 2. This point on the x-axis is still less than or equal to 0. And if we just keep on continuing on with all of these points, we could say that those are all going to be less than or equal to 0 as well. So if it's going to be less than or equal to 0, it has to be any point on the left side of this point 0 here. This ordered pair is 0, comma 0. And the reason why we have this point filled in as well is because of the fact that it says less than or equal to, which also means that we're including 0 into this linear equation. Okay, let's look at the other linear equation being created here. So that's the first one. We finished writing out that one. Now the second one here is f of x equals to 2 if x is bigger than 0. So we can draw the image here where f of x is equal to 2. This is the image for f of x equals to 2. Now it's telling us here that it only happens if we have the image bigger than 0. So it's not including 0. And because of that, we have to cut it where we have an empty circle because we're not including 0, and we're drawing an image where the x points here, for example 1, comma 2, and over here is 2, comma 2. We have here 3, comma 2. All of the x coordinates that are shown in these ordered pairs, they're all bigger than 0. So it satisfies our statement here. So that's what we're going to be doing today. So let me go to the next slide first. So today we're going to be understanding how to read a piecewise function. So the first objective is to learn how to evaluate a piecewise function first. Then the second part is going to be graphing a piecewise function. So we're going to graph it, see what the image should look like. And then after that, we're going to do the last objective, which is to write a piecewise function. So let's start off with evaluating piecewise functions. Right here, it asks us to evaluate the piecewise function f of x equaling to negative x if x is less than or equal to 0, or f of x is equal to 2 if x is bigger than 0. So what I like to do first is I like to separate the linear equations that are being shown in the statement. So right here we have f of x equals to negative x if x is less than or equal to 0. And the other statement that's being given to us is f of x equals to 2 if x is greater than 0. Now they want us to find out what y is going to be if we have x equaling to negative 3. Now based off of the statements given to us, either x can be less than or equal to 0 or x can be greater than 0. So I'm just going to write those here. X is less than or equal to 0 or x is greater than 0. Now if I look at x equals to negative 3, that statement is true over here. Negative 3 is less than or equal to 0. That is a true statement. It isn't a true statement when we have less or negative 3 is greater than 0. That's false, right? So we're not going to use this one right here. So let's look back at the statements here. We said that x is less than or equal to 0. If that's the case, then we have the linear equation f of x equaling to negative x. So I'm going to use this linear equation. So f of x equals to negative x. And then what I'm going to do is do what I usually do whenever I see that I want to evaluate a function. I'm going to substitute the negative 3 for all the x's that I see here. So it turns into being f of negative 3 equals to the negative sign and then substituting the x for negative 3. And that just equals to positive 3. Let's try out the other problem here. The other problem says x is equal to 5. Again, I'm going to, let me erase these parts again. I'm only going to be looking at the statements being made where x is less than or equal to 0 or x is greater than 0. So if x right here, x is less than or equal to 0, that a true statement? It is not, so I'm canceling this one out. I'm going to check this one over here. X is greater than 0. That is a true statement. So since that's a true statement, that means that I will be using f of x equals to 0 because of the fact that since 5 is greater than 0, then I am using this linear equation. So I have here f of x equals to 2. And again, I just want to substitute the x, or substitute 5 into all the x's that I see in this linear equation, which is only right here. So I get f of 5, that just equals to 2. And that would be my other answer. So let's try it out. Let me move things so that you can actually see what the question is. So the question is asking us to evaluate the function when we have x equaling to negative 3 and x is equal to 0. And this is the piecewise function that we're given, where f of x is equal to x minus 2 if x is less than or equal to 0. And then we also have here f of x is equal to 2x plus 1 if x is greater than 0. So I'll give you a few minutes to answer this on your own first. Okay? And let's try it out. So the first one says x is equal to negative 3. Now we're given either x being less than or equal to 0 as said here. The other one says x is greater than 0, which is the other one that's being shown, right? Let me just erase that so you can see the work. So the first thing I want to do is substitute all of the x's for negative 3 to see which one would be a true statement. So here, negative 3 is less than or equal to 0. Is that a true statement? Yes. Over here we have negative 3 is greater than, oops, that looks wonky. Negative 3 is greater than 0. Is that a true statement? No. So because of that, we're going with the linear equation that says that we use this one right here. So f of x is equal to x minus 2 because of the fact that negative 3 is smaller than or equal to 0. So let me clear this to make it cleaner looking. And then let me get my pen out. So right here, I'm going to have f of x equals to x minus 2. And then just like any other linear equation, I'm going to evaluate for negative 3. So I'm going to change all of my x's to negative 3. So I get here f of negative 3 equals to negative 3 minus 2. And so then my answer would be f of negative 3 equals to negative 5. Okay? Let's look at the other problem. It's telling us to evaluate when x is equal to 0. So again, I'm using x is less than or equal to 0. I also have here x is greater than 0. If I substituted 0 for the x here, x is less than or equal to 0, that is a true statement. So I'm going to be using that linear equation. Over here, 0 is greater than 0. That's not true. 0 is equal to 0, but it's not greater than 0. And so because of that, we're not going to be using this linear equation. So we're going to be using the same linear equation again, which is f of x equals to x minus 2, since x is equal to 0. 0 is equal to 0. So for here, I'm going to substitute the x for zeros. Again, the x is going to be substituted for 0. And so I'm left with f of 0 equals to negative 2. And so that would be my answer. Okay. Let me clear it. And let's move on to the next part. Next part is asking us to graph a piecewise function. Now that we know how to evaluate, we want to know how to graph a piecewise function. So we have the two equations given to us. The two equations that are given to us here are y equals to x minus 2 if x is less than or equal to 0. The other equation given to us is y equals to 4x if x is greater than 0. What I'm going to do is just create the image right here. Here is the lines showing the x-axis and the y-axis. And then I'm going to write down right here, this is 1, 2, 3, 4, and 5. Over here is negative 1, 2, 3, 4, 5, 6, and negative 7. Over here we have 1, 2, 3, 4, 5, 6. Down below we have negative 1, 2, 3, 4, 5, and negative 6. Okay, so the first step is to graph out this linear equation here. And the way I'm going to do it is first by identifying what my slope is and my y-intercept is. And since this is already in the format of the linear equation, where it's y equals to mx plus b, I can automatically identify that my slope here, which is the number that's next to, or the coefficient of x, is positive 1. And then my y-intercept is going to be negative 2. And I like to change this into the ordered pair 0, negative 2. That just kind of helps me understand where on the graph I'm going to start. I also like to change the whole numbers into fractions because that tells me the direction of my slope. So since it's a positive 1, I know I'm going to move up 1. And since it's a positive 1 down below on the denominator, I know I'm going to move to the right 1 as well. So I'm going to start off by graphing out 0, negative 2. That point is right here. And then I am told I am going to move up 1 on the graph and then move up again 1 to the right. And I should get this linear equation where I have, let's see if I could draw it nicely so that, oh wait, that's not the line. I want to get the straight line. So this is what it should look like. Something like this. Yeah, that's good enough. That's on one side, and this is gonna be on the other. That's as good as it's gonna get. Just think that this is like a straight line, hopefully. This is supposed to be a straight line, and it looks a little crooked. Okay. So, after we've completed that portion of graphing out the linear equation, the next step that I want to identify is the rule that's being given to me. So it's saying here that the image is only going to be shown when x is equal to 0 or less than 0. So it has to be on the smaller side. And remember that it's on the x-axis. So I'm only going to be looking at the x-axis to identify where my image should lie. Now, since its x is less than or equal to 0, that means it has to be either starting at 0 or it has to be a point on the x-axis that's smaller than 0. And so that includes the order, or the x value, -1, -2, -3. So it's all of these points right here that are being visualized. Now that means that this side of the graph needs to disappear. We actually have to erase it. So I'm going to erase that side that's on the right side of the 0. And again, since it's less than or equal to 0, that means that we are including 0 in this image, which means that I'm going to create a filled in dot right here for 0. Okay, now that we've gotten one linear equation down, I'm going to identify the slope and y-intercept of the next one. So again, we have here y equals to mx plus b. Our m here equals to 4. And then our b, since we have no b, that just means that it's equal to 0. And I can change that into the order pair 0, 0. And then I want to change this into the fraction format, 4/1. That tells me that because it's positive, I'm going to move up 4. And since it's positive 1, I'm going to move to the right 1. So I'm going to start at 0, 0. This is the order pair 0, 0. And I'm going to move up 4. So 1, 2, 3, and 4. And it's telling me to move to the right 1. So I'm going to move to the right 1. That will be my other point. And then let me try to make a line again. Oops. So here is my line. It should look like that. And then it goes all the way down. 1, 2, 3, 4. Should be like that. That one's better straight line. Cool. Okay, so after I have my image graphed, I want to know where my limit is. And in this case, it's telling us that we should draw the image to the point where it has to be bigger than 0. And so that means on the x-axis, it has to be starting at anywhere that's greater than 0. So that includes +1, +2, 3, 4, 5, 6, and then even like this area right here. So maybe +0.5, for example. So we have to include those points too. So the way that we do that is I'm going to erase the left side because the left side, that's not going to exist. And the other thing is that instead of having a filled in circle, my circle is instead going to be empty. Oops, I didn't want to do that. Let's see, I'll just change it to a different color. So my line should, or my circle here, again, I did the same thing. Where's that line? Okay, there you go. So I want, and I'm missing my line still. Okay, there. Now we're good. So I want my circle to be not filled. It's going to be empty. And right here, I'm going to continue on with the line to the right. Just kind of see this as an empty circle. I can't erase it or else it erases everything else, unfortunately. So that's supposed to be an empty circle, not filled in. This one is what filled in circle. Filled in circle. Okay. Cool. So that's how you would graph a piecewise function. Now that we have the graph or the image created, last thing that I need to do is to identify what the domain and range is of this graph. So to do that, let's start off with domain first. If I'm going to be looking for the domain of this entire image here, what I want to do is I want to look at specifically the x-axis. So what points on the x-axis does this image have? What I do know is that it does include -1, it includes -2, does include 0 right here on this image, includes -3 here, -4, -5, -6, and then it continues on getting smaller and smaller and smaller. So I know that for the negative side, it includes all of those numbers. On the positive side, so let's see here, we have here +1 being shown right here. We also have +2 being shown all the way up here because, again, this line is just continuously growing. So either way, we do know that slowly but surely, all of these points right here, the +2, +3, +4, it just continuously keeps on growing. And so because every point is being used on this image on the x-axis for our domain, we could say the domain is all real numbers. Cool. Let's look at the range. Now, if I'm looking at the range, and I'm going to use a different, like a light blue color. Light blue is pretty. Okay. We're going to be looking at the y-axis now. Now, if I'm looking at the y-axis, I don't see I see the image starting at 2. That's like the lowest that this entire image here is being shown. It starts at 2. So I'm going to write that here, that we're starting at 2, right? And it's just slowly getting, or sorry, it's not even 2. It's actually -2. So this is -2. So it's starting at -2. And it's just getting bigger and bigger where it uses -1 on this image right here, right? then it shows 0 being used on this image. It shows 1 being used on this image, 2 being used on this image, 3 being used on this image, 4. And it continues to grow higher and higher because, again, we have this arrow telling us that it just continues going on. And so because of that, we're going to say here that our image, it starts at -2, but it continues to get bigger and bigger and bigger. So we're going to say -2 is less than x. And on top of that, since this image starts off at a filled in circle, I'm going to say -2 is less than or equal to x. And so that would be the domain and range of this entire image here. So, writing a piecewise function. Now, let's say we're given an image, and instead of graphing it, we want to create the notation for this image. I want to start off by identifying the ordered points that are a part of my image. So I'm going to start off with this image right here. And again, I want to just pick out some order points that I see from this image. So one order point that I see here is this point. This is an easy point. It's -3, 0. I also have here this order point, which is 3. Oh, actually that's not 3. That's 0, 0, +3. So based off of these points that are given to me, I can find out what my slope is and y-intercept is. So I have here 0, 3, and I also have here -3, 0. I'm going to start off by identifying my slope. We have here y1 minus y2 divided by x. Oh, is it y1 minus y2? No, it's supposed to be y2 minus y1. y2 minus y1 divided by x2 minus x1. And I'm just going to label these points right here. This will be my x1 value. This will be my, not my, y1 value. This will be my x2 value, and this will be my y2 value here. So I'm going to substitute it into my formula here. And when I do that, I get 0 minus 3 divided by -3 minus 0. And that's going to equal to -3 divided by -3. That equals to +1. After I do that, I want to identify what my y-intercept is. Now, my y-intercept, you can actually see from this image here that the y-intercept being shown is actually the ordered pair 0, 3. That's where we started at, and that's after getting that point, automatically you could see what the slope is going to look like. So I can actually, and you can also look at it from this point of view too, where we have in the first section, 4.1, where we have here 0, 3. We also have here -3, 0. If we want to identify what the y-intercept is, all we have to do is look for the order pair that has x equals to 0. This one does. So that means that our y-intercept here is going to be +3. So I'll point this out. This is our b. So when we write down the linear equation, y equals to mx plus b, we know what our slope is now, which is +1 times x, and we know what our y-intercept is, which is +3. So we get our linear equation, y equals to x plus 3. Then, after we do that, we need to identify where the limit is at with this image. So, based off of the image, the dot shows us Let me use a different color that's more brighter. Use red. So the dot tells us where we start at. We're starting here at 0. Now we could either have here x is less than 0 or x is greater than 0. And based off of the image, we see here that it's on the left side of 0, which means that it's talking about -1, it's talking about -2, all of these points right here. You can see them. This is point -1, comma 2. Over here is -2, comma 1. And if you look at these, the x values here, all of them are smaller than 0. And we're not going to include 0 because of the fact that we have here an empty circle. So that means that we're going to be using x is less than 0. So right here, we can write down y is equal to x plus 3 if x is less than 0. Now we got the first image. Cool. Let me erase this because it's a lot of stuff right there that we don't need anymore. Let's look at the next image. So the next image here, we have the eraser. We have the point ordered pair here. This is 0, comma, -1. That's the first ordered pair. Another ordered pair that I could use is right here. Over here is 2, comma, 3. So I can start off by writing down 0, comma, -1. I also have here 2, comma, +3. I need to identify what my x1, y1 values are. x1, y1, x2, y2. Then after I do that, I can identify the slope here, which is y2 minus y1 divided by x2 minus x1, and that equals to +3 minus -1 divided by 2 minus 0. 3 plus 1, that gives me +4. 2 minus 0, that gives me 2. That equals to +2. So I know what my slope is now. If I were to look at the ordered pairs again that I'm given, 0, comma, -1, and here I have 2, comma, 3. Based off of the fact that we do have an ordered pair where x is equal to 0, I can identify this -1 as my y-intercept, which is also my b. So I have here y equals to mx plus b. My slope was +2. And then I had my y-intercept b, -1. And so my linear equation is y equals to 2x minus 1. Now that I have that, the last thing to do is to identify where my limit lies. So again, I need the color red. Okay, so again, my point starts at 0, right? Since it starts at 0, and it's filled in, that means it's including 0. I'm going to use the less than or equal to sign, where x is less than or equal to sign, or x is greater than or equal to 0. It's one of those two. And based off of the points that are given here, there we have 1, comma, 0. We also have here, no, that's not 1, comma, 0. Why did I say that? Delete, 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 delete. Right here, this is 1, comma 1. We also have here 2, comma 3. All of these points are on the positive side. They're also greater than 0. And so because of that, I'm going to say that it's not smaller than 0, but it's going to be bigger than 0. So y equals to 2x minus 1 if x is greater than or equal to 0. And then after I do that, I have my 2 points. I'm going to create my piecewise function, which is y with the curly sign, x plus 3 if x is less than 0. And I also have here 2x minus 1 if x is greater than or equal to 0. And that would be my answer. Cool. So hopefully this helps. Good luck.